Hello everyone. Problem set number 2. We're actually going to start doing some calculus. That is limits. So, in case you missed it the first time, these little red circles are the ones that I'm going to be doing. Of course, they're not exactly the same, but I'm going to be doing examples like that. So with limits, we have things like this needs to be factored. This, you just plug in the number. This, you use the common denominator, which is 4x, and you simplify this compound fraction. This one, you actually have to multiply everything out and then start canceling. A lot of things will cancel. And then I'll also do one as the limit as x goes to infinity. But first, one like this. So I'm actually going to change it a little bit and actually make it a little more fun. So this one requires factoring, because if you just take a 2 and plug it in there, this would be 2 cubed, so that would be 8 minus 8, which is 0 on the top. This would be 2 minus 2, so that would be 0 on the bottom. And when you have 0 on the top and 0 on the bottom, the answer could turn out to be anything. You need to use algebra. So the algebra that we're going to use, and I'm sure you remember this from intermediate algebra, how do you factor the difference of cubes? So first of all, whatever the things are that are being cubed, you would subtract them. And then the first one gets squared. So when this has minus, the first factor also has minus. And then it changes. Now it's going to be plus the a times the b and plus the b is squared. This last one, it's always plus. So right here, it's the x, so that's what a is. And right here, it was a 2 that got cubed, so the b is a 2. Now this limit part, I actually have to keep writing it until the very end. So on the top, it would factor as x minus 2, and then the x gets squared, and now this has minus, so this has plus. And then this would literally say x times 2, but we usually rewrite that as 2 times x. And then the 2 has to be squared, so that would be a 4. And then what happens with limits quite often is after you start doing the algebra, you will have cancellation. So this x minus 2 and this x minus 2 are going to cancel. But look at what it's really doing. Earlier, I said it's 0 divided by 0. Well, if you plug in a 2, this is 0 and this is 0. So what we're doing is, literally we're canceling x minus 2 and x minus 2. But what that's really doing is getting rid of that 0 divided by 0. Now that I've gotten rid of this division by 0, I can go ahead and plug in 2 for x. So this is going to be 2 squared plus 2 times 2 plus 4. So that's going to be a 4, another 4, and another 4. If there's 3 4s, that's 12. This one is done. Next up, let's do something like this, where this needs to be multiplied out and combine like terms and cancel. So, of course, I'm going to change it a little bit, but the work is pretty much the same thing. So again, if you were to plug in h is a 0, that would cause division by 0, which would not give you an answer, so you need to do algebra. Don't you love algebra? Me too. So I'm going to need to make a little bit bigger fraction bar, and now square this binomial, which means that x gets squared. Then multiply these two things, x and h, and double the answer. So that's going to be 2xh. And then also the h gets squared. All right, next up, distribute this 2. So there's going to be 2x plus 2h. And over here, all I need to do is distribute the negative. So there's going to be negative x squared and minus a 2x. And the whole thing is still divided by h. Now look and see if anything could be canceled. and I see that there's a negative 2x right here and a positive 2x right there, so they're going to cancel. Anybody else? Oh, right here, there's a positive x squared and a negative x squared, so they're going to cancel. And then with all of the terms that are left, this has an h, and this has an h, and this has an h. So what I'm going to do is factor out an h on the top. So factor out an h. This would just become a 2x, since I factored out its h. This would become just plus h. And then this would become plus a 2, because I factored out the h. And, like I think I just said, when you're doing limits, quite often you're going to get cancel, cancel. And now that this, which was causing division by 0, has been canceled, you can plug in that h is becoming a 0. So this would just say stay 2x, and then plus 0 for h and plus 2. Or in other words, 2x plus 2. That one's done. So this right here is limits, but we're actually finding a derivative. There's 3 important ideas that come up again and again in calculus: limits, derivatives, and then integrals. But for now, let's work on some more limits. As promised, what about something where x is going to infinity? So this is similar to number 6. So if x is going to infinity, what you need to do is find the term that's most powerful. Like if this is going to infinity, minus 5 doesn't really count for anything. Even x squared doesn't really count when you compare it to x cubed. Because if x is like 1 billion and you cube it, it's a really big number. I don't even know the word for it, it's so big. So anyway, the most powerful term is x cubed, and it doesn't really matter if it's in the top or the bottom. There happens to be a tie right here, x cubed and x cubed, so that's the most powerful term. Then what you do is multiply the top and the bottom by 1 over that x cubed. Now, if this one had said x cubed and this one said x to the 12th, I would be using x to the 12th and x to the 12th. So whatever, when you look at all the terms, whatever's most powerful, that's what you use right here. Now on the next line, I'm going to leave more space because basically what this is saying is when you distribute, you're going to have 7x cubed divided by x cubed. So what I actually do most of the time is I skip this little red part and I just say, oh, this has to be divided by x cubed. This has to be divided by x cubed. This has to be divided by x cubed. And everybody gets divided by x cubed. You get divided by x cubed and you get divided by x cubed. If you don't know that reference, you should watch Oprah giving away cars. Next up, start canceling. So right here, the x cubes are going to cancel. It's just going to leave us a 7. So the limit as x approaches infinity, this part is just going to become a 7. Over here, one of these x's will cancel, so it's going to leave minus 4 over x squared. On the bottom, this part will become just a 9 because the x cubes will cancel. This one will become 1 over x. And this last one cannot change, 5 over x cubed. All right, we've done the hard part. Now we're almost done. When x goes to infinity, let's just take a look at this one, for example. If you have 1 divided by infinity, so that would say take $1 and divide it into an infinite number of pieces. How big is each piece? Well, if you divide one object into an infinite number of pieces, each piece is going to be so small, it becomes 0. So whenever you have a number divided by x and x is going to infinity, all of these go to 0. which means that all that's left is a 7 on top and a 9 on bottom, so 7/9 is the answer. And now, taking a look at page 2, so this, multiply it out, combine like terms. Guess what we use right there? The conjugate, you're right. And number 9, even though you don't know it at this point, this is actually the derivative. So this is our first time actually finding a derivative using the limits. So I'm going to do one just like this, but instead of 1 over x squared, I'm going to use the square root. By using the square root, it actually is a combination of these two problems. So in a way, I'm doing both of these at the same time. Okay, so it's going to be the limit as x approaches 7. Limit as x approaches 7. This just says f of x, so that's the square root of x. And then this part says minus, now plug a 7 into the square root function. So that's going to be minus, and then the square root of 7. And on the bottom, it's just x minus 7. Then it's time to use the conjugate. So the conjugate of the square root of x minus the square root of 7 will be the square root of x plus the square root of 7. And if you multiply that on the top, you also need to multiply it on the bottom. One of those good old rules from algebra. So then it's the limit as x approaches 7. Once again, when you multiply conjugates, it simplifies very nicely because you just have the first one times the first one, which will just be x. The middle terms are then going to cancel. Then you just need the last one times the last one, and a square root of 7 times a square root of 7 is just a 7. But a positive times a negative is a negative. So it turns out x minus 7 is all that's on the top. And on the bottom, don't multiply it out. Just leave it as x minus 7 was being multiplied with the square root of x plus the square root of 7. And then it's time to cancel. So these are going to cancel. A very common mistake at this point is to say the answer is going to be the square root of x plus the square root of 7 and then plug in a 7. But when you divide these, it actually leaves a 1 on top. So it's going to be 1 divided by this. So it's going to be 1 divided by, and now that I've done this canceling, I can go ahead and plug in a 7 right here because it's not going to cause division by 0. So it's going to be the square root of 7 plus the square root of 7. Oops, I forgot my square root. And the square root of 7 plus the square root of 7 means there's 2 of them that are the square root of 7. Now if you turn this in and left a square root on the bottom like that, that would be perfectly fine. If this said the square root of 49, you would definitely need to simplify that, but you could actually just leave it that way. If you have an online homework system that says do not leave a radical in the bottom, so then you would need to rationalize the denominator. So multiply by radical 7 on the bottom, multiply by radical 7 on the top, and then on the top would be the square root of 7. And then square root of 7 times square root of 7 is 7. 7 times 2 is 14, so there would be a 14 on the bottom. And personally, I think that this answer is perfectly fine. But also, you could rationalize it. Either one would be fine with me. But keep in mind with the online homework, if they ask for you to rationalize it, you would need to do that last step. Okay, so that's problem set number 2. I'll see you back for problem set number 3.